lecture, we will talk about multiplication of polynomials. Let's review the distributive property. Look, previously we have a 3 plus 4 times 5. We know by the order of operation, we should do it 3 plus 4 first, which gives us 7. Then 7 times 5, which is 35. So when we do the multiplication like 3 plus 4 parentheses times 5, we do it actually, we should have a 3 times 5 and then 4 times 5. Because 3 times 5 gives us 15, 4 times 5 gives us 20, so together we have a 35. Then this tells us when we do the multiplication with parentheses, we want to distribute 5 to each number inside. So when a plus b with parentheses times c, we should do a times c plus b times c. This is very important. We actually used this distributive property when we do the addition of polynomials. If you know, previously we have x plus 2x. X is actually 1 times x, because 1 times anything is that thing. So 1x plus 2x is 3x. We combine like terms. The reason we get 3x without doing anything with x is because x can be poured out. So you see 1 plus 2 times x. You do distributive property is 1 times x, and then 2 times x. Okay? You go from here to here, it can go back. That's the reason for combined like terms without any action on x. So x minus 2x, for the same reason, we know x is 1 times x. Here we have a negative 2x, so 1 with negative 2 together is negative 1. Negative 1 times x is negative x. Again, why we just need to do the operations with coefficients 1 and negative 2 is because x can be poured out. Okay, it's like c here. CC can be poured out from A and B. So it's again because of the distributive property. 1 plus negative 2 with parentheses times x. X goes to 1, you get 1x. X goes to negative 2, you get negative 2x. So that's the reason for us to combine like terms. It's because of distributive property. For the multiplication of polynomials, I want to give you the first example is like x times 2x. Here is plus, here is times. So in this case, 2, you keep it, because it's like x is like 1x, okay? It's like 1x. So right here, 1 times 2, you have a 2. X times x, you have x squared. And then 1 times negative 2, you have a negative 2. And then x times x, then you have a x squared. Okay, so it's negative 2x squared. That's one thing. Moreover, now let's use x plus 2. There are 2 terms right here. So there x plus 2 times x by distributive property here is x times x, you get x squared, and 2 times x, you have a plus 2x. And so is the case for this place. X minus 2x, x minus 2 times x. So x goes to each term inside. X times x is x squared, and then negative 2 times x is negative 2x. Try yourself. Negative 3x squared times x minus 3. So in this case, negative 3x squared times x, you have a negative 3x cubed, because here the exponent for x is 1. Negative 3 times negative 3 gives us positive 9, and you keep x squared. Try yourself this one. Now we are done with binomial times monomial. X has one term. How about binomial times trinomial? Because here there are 3 terms. Here we need to use distributive property. We review the whole quantity here as a single C letter. So this big quantity times x, you get that. This big quantity times 3 plus 3 times this big one. Now again we can use the distributive property. X goes to each term inside. X times x squared is x cubed. X times x is x squared. X times 5 is 5x. And here 3 times x squared gives us 3x squared. 3 times x gives us 3x. And then 3 times 5 gives us 15. Now it's time to combine like terms. X squared plus 3x is 4x squared. 5x plus 3x, 3 plus 5 is 8. Keep x. And then copy 15 down here. Okay? So you got to try this one yourself. It's basically right here, x times every term, 3 times every term. So x times every term here, 4 times every term here. After combine like terms, you should have an x cubed plus 3x squared minus x plus 12. That's the answer for this one. Alright. Now, let's look at 3x minus 1 times x plus 5. This is binomial times binomial. This is binomial times trinomial because there are 3 terms. This is binomial times monomial. Now, for binomial times binomial, we do again is we review x plus 5 as a whole chunk here. So x plus 5 is like our C right here. X plus 5 goes to each term 3x. X plus 5 times negative 1 right here. And then, again by distributive property, 3x times x, 3x times 5. Negative 1 times x, negative 1 times 5. So 3x times x, 3x times x gives us 3x squared. And then 3x times 5, 3x times 5 is 15x. Okay? Negative 1 times x, negative 1 times x, which is negative x. And negative 1 times x, negative x. And negative 1 times 5, negative 1 times 5 is negative 5. You can see when we do the binomial times binomial, 3x times x, 3x times x is the first product. And then 3x times 5, 3x times 5 is called outer product, because those two terms stay on the border, out. Now, -1 times x is inside. Those two terms are inside. And then we call this is the inner product. The first, this one is called outer product. The last product will be -1 times 5. So FOIN, first product, outer product, inner product, last product. Together we call this method is FOIL method. Okay? After you get the multiplication for each individual, then you have a 3x plus 15x minus x gives us 14x minus 5 here. We have -5. So this is the final answer. Later on we do this one, we will do the FOIL method directly. So try this one yourself. The first product for your method would be 2x times 3x will give you 6x squared. 2 times 3 is 6. X times x is x squared. Outer product is 2x times -2, which is -4x. Inner product is -1 times 3x is -3x. So -3x, previously we have -4x, together is -7x. And then -1 times -2, we have a +2. This is the answer. Try this one yourself. Okay? Fill out all the steps. Now, look at this one. 2x minus 3a times 2x plus 5a. Again, we need to use FOIL method. The first one would be outer product as 2x times 2x, 2x times 2x. 2 times 2 is 4, x times x is x squared. So the first thing is 4x squared. Now outer product is 2x times 5a. 2x times 5a is 2 times 5 is 10. X times a is also a times x. It is commutative. You can switch ax. Now inner product is -3a times 2x. -3a times 2x. 3 times 2 gives us 6. A times x is ax. Negative. Okay. Now, the last product is -3a times 5a. -3a times 5a. So 3, 5 times each other is 15. A times a is a squared. Negative in front of it. Combine those two like terms. One is 10ax, another is -6ax. So together is 4ax minus 15a squared. Previously we have a 4x squared over there. So this is the final answer for this production. Try this one yourself. 5x minus 2a, x plus 5a. Similar to the one right here. Okay? 5x times x is 5x squared. That's the first product. Outer product is 5x times 5a, so it's 25ax. Inner is -2a times x, so that's -2ax. Previously we have a 25ax and -ax, so eventually we have a +23ax. The last product is negative 2a times 5a, so that's 10a squared with negative in front of it. Try this one yourself. Okay? Fill out all the steps right here, from here to here. Now, 4u plus v squared, how are we going to use Fourier method? You know, 4u plus u with parentheses squared is 4u plus v times 4u plus v, 4u plus v squared. There again, we can use Fourier method. 4u times 4u, 4u times 4u is 16u squared. Outer product, 4u times v, 4u times v. Inner product is v times 4u, v times 4u. The last product is v times v, which gives us v squared. 4uv is the same thing with v for u. So together is 8, 4 plus 4, here is plus 8. uv is vu, so 8 uv. Combine those two lectins. We got that. Now, similarly to this one, we have the one right here. 3a minus b squared. Caution. 3a minus b squared is not 3a squared minus b squared. This is a popular mistake if you write their equal. You should do is 3a minus b times 3a minus b, because a squared means two quantities like this. Do a similar thing right here, then you will find out, do the Fourier method, you will find out 3a times 3a is 9a squared. Outer 3a times b with negative. Inner is negative b times 3a, so together we have a negative 6ab. Negative b times negative b, we have a positive b squared. Alright? Now, the last one. The last one is x times x plus 3 squared. You know, this squared, x on x plus 3, that means x plus 3 twice. So x plus 3 times x plus 3, you got to use the Fourier method. Okay? First product, x times x, you got x squared. Outer, x times 3, x times 3. Inner, 3 times x, so 3 times x. And then the last product is 3 times 3, which gives us 9. Again, right here, x times 3, 3 times x, is the same thing we say 3x plus 3x. So that gives us 6x right here. So we have x squared. Together, those two, 6x, 3 plus 3 is 9 here. Okay? The times 3 is 9 here. 3 times 3 is 9. Now, x needs to go to each term inside. Okay? By distributive property. Then you have x times x squared is x cubed. X times 6x is 6x squared. X times 9 is 9x. Try this one yourself. Alright? That's 3x times x plus 7. Again, you need to do is 3 plus 7 times 3 plus 7. Then you get the answer for 3 plus 7 times 3 plus 7. Then use 3x times 3 quantities inside. Final answer is 3x cubed plus 42x squared plus 147x. Okay? Here, the FOIL method plays a very important role in multiplication of polynomials. So please review that and do some similar exercises, then you will get this part. I will see you in next lecture.